This time we're going to be working out the growth and decay using geometric, but using the nth term, so not as a recurrence relation. So that's our recurrence relation here. This time the nth term is going to be like that. So no n plus 1, we're going to have v of n, and no v of n here, we're going to have v of 0. We're actually going to write the v of 0. We don't need to put down v of 0. Now r, still got to work out our r the same way as you can see there that I've done to the power of n. And if it's reducing, same way, instead of a plus, we've got a minus. That's all. Example 1. Principal value of $10,000. There's our starting value. We are simply use V for value. Is invested into an account earning compound interest at the rate of 9% per annum. Rule for the value of the investment after years is that find the value of the investment after 4 years. Well, that's how we get this 1.09, okay? So 100% is the original. We're adding 9% per annum. So we've got 109% as a decimal, that is 1.09. So that's how we did it. Okay. So we're going to have V of 4 equals 1.09 to the power of 4 times 10,000 to get to 4 years. And when we work that out, we get 14115.82. The amount of interest earned after 4 years. Okay, so if we had $10,000 to start off with, and at the end of the 4 years we've got 14,000, our interest is 14,115.82 minus the 10,000 that we started off with. So we have $4,115.82 worth of interest. Find the amount of interest earned in the 4th year. So just in the 4th year. So the interest earned in the 4th year will be what we've ended up at the end of 4 years minus what we started with at the start of 4th year, or what we ended up at the end of the 3rd year. So we already know the 4th year. This is $14,115.82 minus V of 3. So we're going to do 1.09 to the power of 3 times $10,000 because that's the amount at the end of the 3rd year. Work these two out and we end up getting 1165.53. I'm not putting dollar signs or anything, but we should have them there. In the exam, it won't matter. If the interest compounds monthly instead of yearly, write down a rule for the value after n months. Okay, so it's compounding monthly. We've got 9% being added for the year. And remember, we've got the 100% originally. But divide this. Now we want it months, so we're going to divide that by 12 months in the year, which means it becomes 100% plus 0.75%, and as a decimal this will be 1.0075. Okay, so our rule V of n will equal 1.0075 to the power of n times the original $10,000. Use the rule to find the value after 4 years. That's 48 months. So we're working out V of 48, which equals 1.0075 to the power of 48 times 10,000, which means we get $14,314.05. Example 2. A computer system costs $9,500 to buy, and it decreases. Well, there's our start, decreasing, so it's minus, reducing balance 20% each year, so again 100% minus the 20%, we have 80% as a decimal, that is 0.8, and there we go there. Write down the rule for the value of the computer system after n years. Well, after n years is a recurrence relation. We want V of n, so V of n will equal 0.8 to the power of n times the original $9,500. Use the rule to find the value after 8 years. Write your answer correct to the nearest cent. Okay, after 8 years, so we have V of 8 will equal 0.8 to the power of 8 times $9,500. When we work that out, we get 1593.82. So after 8 years, that's how much it's worth. Calculate the depreciation of the computer after 8 years. Well, depreciation, we bought it for $9,500. It's now worth $1,593.84. So it has gone down $7,906.16. Example 3. How many years will it take an investment of $2,000 paying compound interest at 6% per annum to grow above $30,000, $3,000? Write your answer to the nearest cent. Okay, well, we've got 100%. It's going up 6% per year, so that's 106% divided by 100, 1.06. So we can get our rule, V of n equals 1.06 to the power of n times $2,000. We want this to be 3,000. 1.06 to the power of n times $2,000. So we might as well do solve on this one. For n, how many years does it take? 6.958. Therefore, it's going to take 7 years. Don't leave it at 6.98. Example 4. An instant weaving company purchased a new loom at a cost of $56,000, estimated value of $15,000 after 10 years. Find if the loom is depreciated using a reducing balance, what's the annual rate of depreciation? So we want to find our R. Okay, so our V of n is going to be the original 100 minus the rate, we don't know why that's going down, divided by 100, because remember it's a percentage, times to the power of n times 56. I might as well put this as 10, because after 10 years, we can see the n is 10 years there, and the original is 56,000. And we're solving this, it has to be 15,000 here, 15,000. That's what it's going to get to. 1 minus r over 100. So power of 10 times 56. So when we solve for r, we get r equals to 12.34, or r equals to 187.05. Of course, we're not going to reject this one. We're going to go r equals 12.3. It says 1 decimal place, so 5.3%.